Good morning, students. Am I audible? I hope you have got the info regarding your first sessional exam, right? Everyone, have you all got the schedule of first sessional exam? So, for this subject, it is for real water supply and on-site sanitation. Uh, you can study up to the last class, okay? From start to the last class. It means the last 2 weeks, whatever we have discussed about the subject, you can study for the first sessional exam, right? Is it clear? So you need to study about starting from the first class, that is importance of drinking pure supply of drinking water. Okay, then treatment process, different parameters of the water quality, all these things. So in this today class also, we're going to discuss about some property of water only. That is, we are discussing about chemical property of water. Fine. So last class we have discussed about physical characteristics of water, like turbidity, color, odor, temperature. Okay, and this is all related to your previous semester environmental engineering subject. I hope you all know these things. So it will be, it is kind of your advantage that you already know these things. Only you need to go for revision of that particular subject. That's it. So today also we are going to discuss about something related to your chemical characteristics of water, drinking water. I'm not going to in a deep um, information, okay, or deep discussion. I'm just going for your kind. You can take this as a revision class for your last semester. So I think you know different characteristics come under chemical characteristics. I'm talking about different chemical characteristics of a water sample. Okay, and chemical characteristics, it mainly depend on different dissolved substance present in water. Dissolved substance, like I'm talking about the minerals. Okay, and based on the presence of different minerals present in water, water may be classified under different characteristics. Like if water contain higher amount of uh, hydrogen ion producing substance, that means I'm talking about the H plus ion. Okay, H plus ion, the presence of H plus ion represents what? The water is acidic, isn't it? And in other hand, the presence of OH minus ion represents just the water is basic. or alkaline water. I think you know these things, right? So we need to find out whether the water sample is contain acid producing minerals or basic producing mineral. Okay, and you also know about the pH. So pH, that is what? Potential of hydrogen, or POH, potential of hydroxyl ion. Okay, that means the chemical characteristics of water depends on the presence of H plus ion and also presence of OH minus ion. And that's why we need to find out the pH value. Okay, even in the last semester, I hope at least you have gone through that part, your laboratory test. I don't know, I think in the last 3 months in the pandemic session, right? That means you are not going for practical physically, but at least from your from that YouTube video or whatever, from your the notes given by your previous class teacher, you get this idea about the pH, right? So pH is one of the chemical characteristics of water. Okay, so pH, similarly like presence of iron. Okay, it is also a chemical characteristics. Then hardness of water, alkalinity, acidity, all these things are come under your chemical characteristics of water. Okay, so let's start our class. I'm going to present my screen now. So yeah, you can see in a list of chemical characteristics of water. Okay, we're not going to a detailed discussion about all these things. I'm going to just give you an overview of all this. Fine. So whenever I say, I already told you what is the basic idea about chemical characteristics. It's actually uh, deals with the presence of dissolved minerals or dissolved substance present in water. Okay. So, but we need a balanced. Okay, we need a balanced amount of chemical in a particular drinking water. If you consider drinking water, we need a balanced amount of minerals. Okay, that means if the particular water is having no minerals, it is not good for our health. If it contains too much of mineral, it is also not good for our health. Okay, we need some balanced um, proportion of minerals. Got it? So here you can see, I guess, the chemical characteristics are like pH, acidity, alkalinity, hardness, presence of chlorides, sulfates, iron, different kind of solids, nitrates. All these things comes under chemical characteristics. Okay, and when I say pH, I already told you it represents what? It represents presence of hydrogen ion. Okay, and how it represents negative logarithmic of H plus ion, right? So let me give you that part. Let me check how to represent pH, right? Let's find out pH formula whether it is given or not. Let me check. Somewhere will be there. This thing also very important. Let me. So basically, what is the full form of pH? This is also very important. Potential of hydrogen. Okay. In some interview also it may ask. Okay. Potential of hydrogen. That means how much hydrogen ion is present in a particular water. Okay, it's very important. Okay. Similarly, if in place of H I write OH, it will be represent potential of hydroxyl ion. P for potential, or you can say in other word power, H for hydrogen ion. Okay, so I'll tell you how to represent. Wait, what is the formula? There has to be some formula. I think here it is written here. You can see this minus log H plus. It represents pH. Okay, this is as a whole. These things represents your pH. pH. How to represent pH? pH is the negative logarithm of H plus ion. And if I say POH, then it will be negative logarithm of OH minus ion. Okay, and if I combine H and OH minus, H plus and OH minus becomes what? Water only, right? So in water it presents H plus and OH minus also. Okay, but what is the percentage of H plus ion and what is the percentage OH minus? That is very important. Okay, fine. And depending on the presence of here you can see the pH meter. From the pH meter, you can determine whether the water is, okay, someone is waiting. Wait, whether the water is acid or basic or alkaline. Okay. So anyway, you can see the scale here. I think somewhere it is scale. You can see the scale. Let me zoom it out. It's not coming. Yeah. So here you can see this is a pH scale. Okay. So even in the notes even given here, pH value denote what? Whether the water is acidic or alkaline. In okay, whether the water is acidic or alkaline. Okay, and it is expressed on a scale of 0 to 14. Here you can see 0 to 14. Okay, so the value of pH it ranges from 0 to 14. It will not cross 14. It will not go below 0. Fine. These things are already known to you. Okay, which is a common logarithmic of the reciprocal of hydrogen ion concentration. That means what is the hydrogen ion concentration is present in a particular water? It reflect pH. And which is very important, next line, the permissible range of pH of drinking water, treated drinking water. Okay. Okay, that means your water must the pH of water, the pH of water of I'm talking about drinking water actually. The pH of drinking water must be ranges between 6.5 to 8.5. Okay, in very frequently it will come in different exam also, and in vibe also it may ask, even in the exam purpose also very important, the range of every component. Okay, range of pH, acidity, hardness, all these things. So pH of treated drinking water must be ranges between 6.5 to 8.5. Okay, 6.5 to 8.5. Let me suppose here from 6.5 somewhere here to 8.5. This is the, you can see the green colored area. This is for pure water. Okay, okay, this is your pure water. And you can see the below, if the pH value come below 7, it become acidic, and if the pH value come higher than 7, you can say the water is alkaline water. It contain OH minus concentration higher than H plus ion. Got it? So if you can understand this scale, it is very easy to understand all these things. Okay, so based on pH, based on the amount of pH, we can say whether the soil is whether the water is acidic or whether the water is alkaline. Okay, so acidity means what? It actually represents the presence of H plus ion. The acidity of water is a measure of its capacity to neutralize base. That means if you have H plus ion higher, or then it can neutralize OH minus whenever it get contact with H minus ion. That means it have the capability to neutralize base. Okay, since acidity means what? It contain H plus, and base contain minus. Okay, that means cation and anion they can neutralize each other. That's why it's given here. An acidity of water is a measure of its capacity of neutralizing base. That means suppose you have a high acidic sample of water, if another sample you have a basic water, so if you mix together, then you can neutralize the base, okay, in a particular sample. Okay, and basically where it come from, this acidity? Okay, the acidity water mainly because of the presence of carbon dioxide, which is unbound, okay, uncombined carbon dioxide and other mineral acid, like H2SO4, HCl, like that. Okay, it's come from naturally mineral acids and other salt of strong acid. Strong salt means what? When some uh, strong acid react with strong base, okay, the result is called the salt of strong acid. Okay, you can also search in Google. If you still have any doubt, you will get the idea about what is salt. So because of the presence of uncombined carbon dioxide, then mineral acid and other salt of strong acid, even weak base, because of the presence of this, we can say the acidity of water rises. And it is expressed, this is also very important, it is expressed in terms of milligram per liter, in terms of calcium carbonate. Okay, so even in the experiment, to find out that acidity or alkalinity or even hardness of water, it is always determined in terms of calcium carbonate, remember. Okay, it is expressed in terms of it is expressed as milligram per liter in terms of calcium carbonate. It is normalized in the form of calcium carbonate. Okay, CaCO3, fine, calcium carbonate, CaCO3. Okay, so this is all about acidity, and next we'll discuss about your alkalinity. Same like acidity, it is kind of opposite of acidity. A particular water sample having OH minus concentration higher than H plus concentration, that the soil, you can say alkaline water or basic water, fine. And the alkalinity of water is a measure of its capacity to neutralize acid. You can see the first line is completely opposite. Acidity of water is a measure of its capacity to neutralize base. In other hand, the alkalinity of water is a measure of its capacity to neutralize acid. That means if a particular sample is so alkaline and okay, it have the capacity to neutralize an acidic water, since it contain OH minus and other sample contain H plus. Okay, so then you can neutralize each other. Okay, fine. So this one also expressed in terms of calcium carbonate and expressed as milligram per liter. That means how much milligram per liter of alkalinity present in 1 liter of sample. Okay, in 1 liter of sample, what is the amount of alkalinity we can determine. And the causes of alkalinity, it mainly come from your hydroxyl ion. I already told you, OH minus. Similarly, carbonate alkalinity, okay, from carbonate also it come from basically carbon dioxide. Okay, carbonate alkalinity, then hydroxide plus carbonate, the combination of hydroxyl and carbonate ion. Okay, like that. The different bicarbonate also one of the important uh, cause of presence of alkalinity in water. Okay, you can also remember this alkalinity is very important parameter to evaluate the optimum amount of coagulant. You know what is coagulant? If you remember the water treatment plant, we have a step coagulation and flocculation. Do you remember that? Flocculation and coagulation. In that step, what we do? We use some chemical. Okay, we add some chemical into the water. And what is the technical term for that chemical? It's called coagulant. Okay, we use coagulant. And what is the property or significance of the coagulant? It makes a paste, or you can say it kind of binding property. This particular coagulant have a binding property. It mixes with the suspended solid present in the water, and they make a film, okay, sticky film around the salt particle, and they make a flock, or you can say all soil particle they come close to each other and make a flock, a kind of a ball kind of structure. Okay, and they get settled in a particular sedimentation tank. So basic idea about using coagulant is to make the flock into the water treatment plant. Okay, so different example of if you want to know different type of coagulant, so examples are like alum. Okay, alum, alum. Okay, alum. Alum is a kind of a coagulant, and if I say the chemical formula for that, it's Al2SO4 dot 18H2O. Okay, that means it contains aluminum sulfur dioxide along with water dot H2O. Okay, alum. What is the chemical name of alum? It's aluminum sulfate. Okay, you can search in Google. So you can use aluminum sulfate, then copperas, okay, or chlorinated coppers, or sodium aluminated. Okay, all these things are used as a coagulant for treatment of water. Okay, so what is the amount of coagulant can be used? It depends on the alkalinity of water presence in particular water sample. Okay, so this is all about your acidity and alkalinity. It's also related to your hardness also. So you know what is hardness and softness, or you can say hard water or soft water. It basically depend on what is the percentage of mineral present in water. Okay, if you know that I already told you that when rainwater drop come from the sky. Okay, when the rainwater drop just come from the cloud, it is actually a soft water. Okay, it doesn't contain any minerals. Okay, it only contains some amount of salt. Okay, that's why if you can taste the rainwater, you can feel some salty taste. Okay, it's very soft water. It doesn't contain any minerals, only contain a salt. But when it come close to the earth, and when it come in contact with earth, it uh, combined with different minerals present in soil. Okay, and it become rich in minerals, and it become hard water. Okay, that means hard water, you can say hard water contain higher amount of minerals, soft water contain less amount of mineral, in a simple way. And you can also say the hard water uh, creates soft soap. Okay, or later it can produce more later. Okay, so hard water and soft water have different advantages and disadvantages. Okay, in some way it is good to use soft water somewhere. Okay, and somewhere it is bad to use hard water. Or okay, so you can also find out what is the advantages and disadvantages of uses of soft water and hard water. Okay, you can find out by yourself, and Google find out is very interesting. Okay, so you cannot wash your if you wash your clothes with hard water, you will see some spot or dark spot in particular your clothes, because of the presence of the different minerals. Okay, it produce too much of foam, or you can say it's produced too much of leather. Okay, okay, here it is written also here, if water consume excessive soap to produce leather, it is said to be hard. Okay, and it is because of the presence of multivalent cation. Cation means that positively charged ion. It is due to the presence of multivalent cation, and this multivalent cation like what? Magnesium. Okay, sodium, magnesium, all these things. Calcium, magnesium, all these things. Okay, they are multivalent cation present in water. So this multivalent cation react with your anion. Okay, anion present in water. Fine, and they produce hardness. The hardness is caused by divalent or multivalent cation, and the principal hardness causing cations are what? Calcium, magnesium, strontium, ferrous, and manganese. Manganese ion. Okay, that is Mn. Calcium, magnesium, strontium, ferrous, and manganese ion. Okay, and the major anions associated with this cation. That means I already told you that this multivalent cation reacts with your anion present in water. And what are the anions? The major anion associated with these cations are sulfates, carbonates. Sulfates, carbonate meant what? CO3, okay, minus or CO minus, bicarbonates, okay, chlorides, Cl minus, nitrate, NO3 minus, like that. Okay, that means this calcium, magnesium, okay, ferrous, strontium, manganese ion presence having plus, okay, that means they are cation, and other these are anion, okay. So they combine together and they form hardness in water. This is already you have got this thing in last previous semester also. So this particular hardness also represents in terms of it represent in milligram per liter in terms of calcium carbonate. Okay. So there are basically two type of hardness. This is also very important: temporary hardness and permanent hardness. Okay. So basically, your temporary hardness caused by your carbonate and bicarbonate ions. Okay. Temporary hardness produced by carbonate and bicarbonate ion like CO3 and HCO3. Temporary hardness. Okay. And a particular water, if it present both soft your temporary hardness and your permanent hardness, if you can boil your water, suppose the water is impure, you want to purify the water, usually what we do, we boil the water. Okay, but boiling is not enough, because from boiling you can only remove that temporary hardness of water. That means the hardness caused by your carbonate and bicarbonate. Okay, that is that is your HCO3 and CO3, carbonate and bicarbonate hardness, and they are termed as temporary hardness. That means from boiling we can only eliminate the temporary hardness, but to remove the permanent hardness, okay, we have to go for different treatment process like addition of lime soda. Okay, you can use addition of lime soda. Using lime or soda, you can remove permanent hardness from water. Okay. Yeah, even Indian standard also provided some ranges for hardness. It should be ranges. The highest value for drinking water is 300 milligram per liter as CaCO3. Okay, it is a Indian standard range or amount for hardness of water. Similarly, the presence of chlorides, presence of sulfate, then presence of iron, then presence of uh, nitrates. Okay, all these things are also have some permissible range. Okay, you cannot or you don't have to remove all these things completely, but we need to maintain the range. Okay, like for iron, you know the iron, no? Even uh, in natural water contain the iron. Okay, but for desirable for drinking water, the amount of presence of iron in water is about 0.3 to 1 milligram per liter. Okay, similarly solid, I already told you a different type of solid may present in water: suspended, dissolved, or settleable. Okay, so we need to also identify what is the amount of total solid present in water. Okay, you heard the term TDS meter, right? Total dissolved solid, TDS meter. TDS meter is used to uh, find out what is the uh, tolerable limit of solid present in water. Okay, I'll show you if you want to find out what is TDS meter. Okay, let me check. I'll show you here. So even this one, here you can see digital uh, TDS meter is there. Okay, even online also you can find out. So what is TDS meter used for? Let me check. So total dissolved solid meter. Okay, so it's basically used to determine what is the amount of presence of dissolved solid in water. Okay, so it is very important chemical characteristics water. So likewise, so basically IS acceptable limit for total solid is 500 milligram per liter, and tolerable limit is 3000 milligram per liter. That means you should not cross 3000 milligram per liter, but for desirably it must contain 500 milligram per liter. Okay, so it is all about your solid part. Similarly, iron also I already told you. Basically, it's come from your ferric oxide. Okay, from ferric oxide the iron comes into the water. Okay, it's all come from actually from soil. Fine. When water come in contact with soil, from the soil mineral comes into the water, like iron, sulfates, chlorides, okay, different solids, nitrates, all these things may come into the water. So for each component we have a desirable limit. For sulfates, which is come from your sulfate mineral, okay, present in soil, it's come into the water, and it should be less than 50 milligram per liter, and for some industry, and for drinking purpose it is 150 milligram per liter. But this ranges must be, you must remember this range. Okay, this one also very important. Okay, so all these things about today class. One thing left behind this bacteriological test, you just read by yourself. A simple sentence is given here. uh, why we need to go for bacteriological test. That means for microorganism present in water, we need to go for tasting. Okay, and we need to identify that dissolved or microorganism by using a microscope. Okay, so you need to go through. You just go through this paragraph. So this is all about today class. Okay, in this class we discuss about different chemical characteristics of drinking water quality. Fine. With this, your first module is completed here. Overall, clear? So I'll just close my sharing here. Is it clear to you? So this is not included in your first session exam. Okay. So up to the previous class, you can study for first session exam. Correct? Any doubt? So if you don't have any doubt, so first of all, I just close my recording. After that, I'll take your attendance. I'm closing the recording. Okay.